Yeah, I'm checking
We
here.
are coming live,
We
everyone.
are coming yeah. live. Oh, we
Ooh, I got echo. That's horrible. There we go.
I
Now no
yeah.
echo. Now no echo. Hello, everyone, and welcome to a one-off live stream. This is a very special live stream here. We didn't finish last week's as we were going through some workload, and we decided to come back and take a look at what's going on our two Postgres servers that we had set up last week to see what we can do to make some modifications and some tweaks. So, yay for us. So, we're excited about that.
Yeah. Hey. Okay. Hey there, Matt. Yeah, we left last week with some optimization, right? So actually, we started taking a look on your server. So if I might share my screen, yeah. I was just logging into your server here to see what we have, and this is what I have from PMM. So we have some load, right?
Oh my, we have some load. Yes, we
We
do.
do, we do.
Yes, we do.
So
And look at that beautiful non-uniform distribution.
yep. Last Let me get just the last 3 hours to see here. Is to zoom in what we have. Look, you
Oh,
are
look,
doing
Gonzalo
some.
joined us. Hey, Gonzalo. This is a stream. We didn't figure many people would stop by because we didn't announce it on purpose. Because this is a follow up to kind of finish our live stream from last week, and probably be a good to put the two recordings together. So, but I do have a new hat to show off when before we're done. So that's important. I visited our esteemed CEO today, and he brought me a new hat. My dogs think it's a chew toy, though. So this is my new hat. We'll put it on in a little bit to build the suspense, to keep the audience watching us, right? We want to have them pay attention as much as possible to the stream. So stay tuned for the hat reveal. It's coming up.
So today is not only my suffering here to figure out the problem in your database, right? So we have this
My
happening.
suffering.
Yeah,
So
you
mean.
know, this is the DBA's life. You know,
So
the
mean.
customer goes there and do something. Like I know you probably did something. Yeah, you know, just
Who,
to
me?
catch
Why would I
it.
do something?
Yeah, you know.
Why would I do something?
All right, let's start. So
Yes.
what we left from
Well, we
last
changed
week.
the shared buffers last time. That was the big change.
Yes, we did change
And we saw a
the shared
significant
buffer.
increase in overall performance.
Okay. So from what you've seen during the week and your load test, do you still have this performance improvement?
Yeah, well, so it is still performing better, but we
Okay.
are seeing some errors now.
Okay. Which are?
Uh, we're actually hitting connection limits.
Oh, now we are hitting connection limits. But as I remember, you had it at 200 connections, right?
I believe we only had it at 100. If we go look at the top, I think max connections was set to 100 on this box.
Yeah. We can check it
So
here.
you
Yeah.
can see, like right below, you see the Postgres connections. You
Mm-hmm.
can see where it hits over 100, right?
Yeah, it does. It does.
Yeah.
It sometimes tries to go over the limit. And this is interesting. How it possible if you have 100 connections limit? This graph here shows you 200.
This is a good question. Tell us,
Yeah,
Charly.
that's a good question, right? So, well, how is that possible?
I
Any
said,
hint?
tell us, Charly.
No, that's my question, right?
They're idle
See,
connections, right? So most of them are sitting
yeah,
in
the
an idle
total
state.
number of connections here. See, we have like 89 active, some idle in transactions, and it should not go over limit, right? It should not go over 100 connections because it told the database to limit to 100 connections, right? So what happens if I go to the database now? Let me connect here as your Postgres.
It'll probably let you
And,
through, by the way, because I don't think we're at 100 right this second.
okay. So if yeah, right now, the start activity just shows like around 50, 52 connections. So why sometimes we see this over limit number of connections? Still my question. And any guess, any hint?
Any hint or guess? So you're making me pick again? I told you
Of
that I
course,
don't like
that's
that.
the idea.
I want you to guess for yourself. So there's actually a couple things that I can think of. Number one, it
Uh,
can be a metrics issue. So because of how PMM's collecting metrics, it could be counting metrics that are between cycles, right? So you might see at the point in time where it collects the Postgres connections merged with a second or third poll, and they might show as different, right? So
mhm.
that is a possibility. Sometimes you'll see what we call metrics jitter in some metrics where you'll average two numbers together and it will not make 100% sense. So that is a possibility.
Yep. Especially for database like Prometheus and Victoria Matrix. Sorry, it sometimes happen quite often. Yeah, that's one of the possibilities. Any other thing that you could think
Well, if
about?
you look at the connections next, you see the max connections actually does pass or stop at
Mm-hmm.
100. So we are only getting up to 100 active connections at one time, which means
That's
that
true.
the other connections that are being listed are not active.
That's true. And we have here another thing that we need to take in consideration where this metric comes from. Uh, when a connection dies for the endpoint, let's say we have, well, for client server architecture, we should have two endpoints, right? We have the client and we have the server. So we have the Postgres client and the Postgres server database. So from the TCP point of view, when you open the connection, everything goes fine. So we have those two endpoints. When you close the connection, they don't immediately close the from the connection point of view, right? So you still have on those endpoints the connection live for a certain period of time, and depends on how we collect that matrix. It can count as an still open or active connection or from the database point of view. So even for the Postgres, that connection is not active anymore, but it's still live from a TCP stack point of view, right? And this is important to notice and understand, especially when we have a proxy in front of the database. Let's say we have a PG bouncer or an AG proxy. If we have a configuration problem from the Postgres side, or if we have certain timeout limits too short on the database side, and database, the Postgres start closing the connections by itself, those quadruples, that is client TCP IP, client TCP port, server IP, and server port, they're gonna be busy usually for like 2 minutes. That is the timeout for the Linux stack to release them. If we have too many closing connections from the database side, and they all coming from the proxy, eventually we're gonna reach the max number of the connection that is allowed for the Linux kernel to accept from that node, in this case, from the proxy. So even though we might not have any live or open connections from the database, then the proxy will not be able to connect to the database anymore because it's being restricted by the kernel. It's a common problem, for example, for websites. When we have something in front of your website, like an AJ proxy in front of Nginx or Apache. So it's something that can happen quite often, especially for configuration problems. So if you have a misconfiguration, it can also happen to the database, right? And when we see something like this, it's worth investigate if the problem was just about metrics or if the problem is just what I told you. We might have a misconfiguration problem here.
Okay.
right? So we might have like something from your database closing connections, because the problem is who closes the connection? If the application closes the connection, so is the application that needs to wait for the kernel, for the OS stack to release that spot on the connection timeline. If the server closes the connection, then on the server side, it has to wait. So, and we might have this implication, right? Let's keep just a note for now, because this is not what we're for today. Today we want to look at performance, but
well, all configuration, and obviously, if users can't connect, they have no performance.
Well,
you can't deny me that.
Depends. Well, if my database has no queries, it's quite fast. I can tell you.
But right? users are what matters, right? Users are what matters.
I agree. I try to escape that one, but yeah,
you can't escape that. You can't escape that.
All right, yeah, but let's keep it. It's a note. So this is something that worth investigating, right?
Yes.
But right now, so if we look at the application, you're saying that the application is hitting the limit, the number of connections, right? I don't think it's doing right now because I can't see from the graphs.
Yeah, so it was at a certain point, and then it backed off.
Here, yeah.
Because you know what? Users couldn't connect, so they said, screw you guys, we're going to a different website. That's what they said.
Yeah.
That's what happened there. They all hit, they couldn't get on, and they went away.
Which is bad. It's not good.
Yes, that's of course it's bad.
Okay, yeah, it's not good. All right. So let's check here. How is? Oops, it seems okay. So while I'm here on the database, I want to check some parameters, right? So usually the most common way that people go is to do like something like show all and check all the parameters here. Right?
That's a lot of parameters though, isn't it?
Well, they do. We can also go here on KMM, right? So we can have something similar here. On the settings here. So this is
a little easier to read.
Yeah, I was about to say the same. It's a lot better to read, right? So, and we can have some settings here that we usually the most we can put here. Okay, so as a client, would you like to increase the number of the connections so you wouldn't have the same problem again?
Yes, I want you to put it to 100,000 because I never know how many I'll need.
I would love to put it at 100,000, you know, like, well, I have like a wild guess that would not work quite well for your setup to have 100,000 connections.
What?
It's just a wild guess. I might be wrong, but it's just a wild guess, right? Because, well, you have a 32 gigabytes machine, right? Or 8 gigabytes box. So let's say we have a 32 gigabytes box, if I remember correctly.
Yes, this is 32 gigs.
Okay. So we have.
And by the way, are you going to do math?
No, no.
No math. Okay.
No,
so I was going to say, if you were going to do math, I was going to shut my camera off and go to sleep.
No, I just want to say that, like, we have some limitations for the number of connections. We have some things that they put physical limits for max number of connections, right? So for every connection that we get to the database, we need to use some portion of memory, right? So
correct.
Then if you have 32 gigabytes memory in your box, you need to have some memory available for those connections, for each of those individual connections. So they have some buffers, like, for example, sorting buffers, the query buffers, so those buffers, they're going to use memory, right? So, but you also have an operational system on your box, don't you? And the operational system.
I mean, it's just the database.
Yeah. So, and unfortunately, the operational system also needs memory. So we cannot use all up to all the memory that we have for the database. Another problem, but this is the most common thing that people use to tell the users they cannot increase the number of connections, because you have a limited number of memory, right? But what if your database had 1.5 terabytes of memory RAM? So would you be able to put like that 100,000 connections? What do you think?
No.
Let's say you have 1.5 terabytes RAM.
Wait, let me put on my thinking
That's quite
cap.
a lot of memory,
Should I
right?
put on my thinking cap?
So do you think that
The answer
we could...
is no. I don't think that is possible. My thinking cap says that
why?
you will hit some limits there. And by the way, if I had 1.5 terabytes of memory, I would have to be filthy rich, and so I would pay someone else to figure that out for me. Just saying.
Yeah, no. The thing is, some people, they like to do those, even though they have plenty of money to pay for someone else. They like to be involved and
Yes.
do things. And there's nothing wrong with that. If you like such a person that you like to get your hands dirty doing things, that's fine. Well, I probably would also pay for someone else to do that thing for me, right? Anyway,
see, I knew that you were like me.
It's just
yeah. So I mean, obviously the memory constraints at that many connections and just managing that many connections is going to be too many. And I mean, any database is going to start to fall over dead pretty quick as you start to open that number of connections. It's not just the memory that's constrained at that point. You've also got CPU concerns, and you're going to have weight conditions and other things that happen. So obviously there is some limit, and that's why connection pooling is so critically important, especially considering that your active throughput is going to be limited by the number of cores and the number of things that's going to be active anyways. So unless you're going to match that 1.5 terabytes with a 10 million core box, you might not get the results that you want.
That's a very important thing.
Of course it's important, because I wear my elephant hat and it totally told me that was right. Elephants are wise, right? Or is that owls?
Yeah, they are. And they have really good memory, right?
Of course they have good memory.
So yeah, and that's a very important thing. CPU. So when we're going for the database, we have a lot more to deal with other just memory and IO, right? I've seen people talking about IO, how badly it can impact on performance.
And it can.
Yeah, they're right. Yeah, IO can really be a huge problem when you have IO saturation. And we've seen on the last talk how badly it can impact on performance. Right? But when we also start to get into the CPU saturation, it can be really, really bad. As you said, we have the physical limitation, as it doesn't matter how fast the CPU is. The CPU still can only do one job at a time, right? So one CPU core can only do one job at a time, right? So, and if you get for that number of connections, let's say the 100,000 connections, so, and let's put, we can put, I don't know, 1,000 cores, 1,000 CPU cores in our box. Well, doing really simple math, every core needs to deal with at least 100 connections at a time, right? So that would put a huge pressure on the CPU, and it will start to go really, really slowly. Do you want to do something?
Ooh, what do I want to do?
Play around.
You can play around with this box. That's fine. I just have to restart the workload.
No, yeah, it's fine. I just want to change here. It's not mistake. It's only TC PostgreSQL. Okay, 13 main PostgreSQL.conf. I want to put here to 2,500 max
2,500.
connections.
You are a madman.
Yeah. No. I don't want you to put 2,500 connections. I just want 1,000. But I want the database to be allowed to accept 2,500, right? So, and let's start slowly just with 1,000. If I don't mistake, we need to do a manual restart here, right?
Yes, there was something wonky with how that one was set up. We didn't go back and connect the service CTL. The services.
We can do it later, but right now, so what I'm gonna do, okay, this is the start. And okay, do we have a stop here? No. So is there any problem to send a queue to all those signals on Postgres? What do you think?
Well, we talked about that before. It will have to recover from them, so it is not a recommended best practice to kill.
Okay.
We covered that in the last one because you had to kill this instance before. We should really fix this instance or change over to the other instance that is not kind of wonky.
Well, that's fine. I just want to show you that we do have different signals when we send a queue.
Oh,
right?
yes,
so
yeah.
I want to just send a sig queue, right? I don't want to send, because when we stop the database, when we stop Postgres, actually what it does, it sends a sig queue to the database. A sig queue is a gentle request to the database that just asks the database, can you please stop, right? So, and actually this is what the systemd does. When we do the systemd Postgres or whatever service is stopped, it will send a sig queue to that service, and we wait because, well, the service might be doing something during that time, and eventually it will just stop, right? This is what I'm gonna do here. I'm gonna do gonna send a sig queue. I'm not going to do a Q-9 because a Q-9 is it's a huge problem. And I know you know why. And I'm gonna ask you why a Q-9 is a problem for the database.
Because it pulls the rugs out of everything. Like underneath everything, it just hardcore crashes and shuts down. Right? It's like stop, don't wait for anything, don't wait, just wipe it clean.
Yeah, but why is that a problem?
Because there's still things in flight being written. There's operations that may be kind of in a wonky state. You want to kill as gracefully as possible or shut down as gracefully as possible.
Yeah. That's true. So, and for databases, remember we have a lot of caches on the database, right? For example, for this instance, we gave to the database 6 gigabytes cache. If we're writing to the database every time that we do a commit and we do an update and whatever operation that writes to the database, it does not immediately write down to the disk. It might be on some sort of cache for the database, right? And when we do a Q-9, as you said, it doesn't wait for anything. It just cuts off the head and it's gone. So if we have any cache or anything in the cache that still needs to go to the disk or needs to be asked to the OS to be flushed, it won't have time to do so. That's why we always want to send a gentle sig queue. See? It didn't do immediately because it was doing its own cleanup, but now it's gone. We don't have here the Postgres services anymore, right? So that was the gentle ask to the database. As you see here, there were some service, they were doing some cleanups and some stuff that's still needing to be processed. And when it was done, the database just found that it was time to go and rest in peace. So that's why it's so important to do not send a Q-9 to forcefully kill the database unless it's extremely necessary.
Yeah, last resort, because the recovery is questionable And so if you do a kill-9, there might be data loss or corruption or some other
Indeed.
fun things that happen. Actually,
Yeah.
if you want to have a very eventful and exciting day, go ahead and kill-9 your database. Yes, everyone out there, if you're looking for some fun this weekend, go out to production and do a kill-9 and tell them Charly told you to.
Well, and I can even show him here. They can take just this would be the nice command, and we'll kill everything that has Postgres, right?
Don't
so
do
this
it.
is the amazing command.
Don't do it.
But don't do it. It's
do
just
Don't do it. Don't do it. Don't do it.
Don't do it. Don't do it.
All right.
Not help.
So is it? Did you start it? Is if you started
No,
it,
not yet.
restart the
I'm
workload?
starting now.
Okay.
Yeah, I'm just now. Let me take a look here. Where is my instance? So, okay, every 1 minute. I want to be a bit faster. Let me put here to the last 15 minutes so I can see it better. Yep, we have an interruption just here. And it's back. It should be back. It is back. And here we have, I can see some load here.
There you go.
Are we? And see, we're up to almost 3,000 connections. So what is the max connection that you put for your load?
I could put it as whatever you want. You want to see? You want to see a lot of connections?
Yeah, I would.
Who
like
wants to see a lot of
1,000,
connections? How many do you want to see?
I think 1,000. It's fine. You have a big box.
Right? Yeah. The only problem is you're going to run out of resources on the app server because I'm running a single app server right now. But this is actually a very easy change for me to do. Let me go ahead and.
I just want to know what gonna happen if we have 1,000 connections.
Okay, fine. Just give me a second. Jeez, you are so impatient. Has anybody ever told you that your impatience is not fun?
Well, honestly, probably more than us.
Okay, so how? Why don't I just go to like 150 or so real quick, and then we can adjust from there. How does that sound? All right. Because like I said, I'm not sure how much the app server that I'm using can spin up. Python threading
does
have some
extend the limits, right?
Yeah. Yeah, and I mean, this is where, like, from a Python perspective or your application server, there's also going to be limits there on how much can be thrown to the database as well. And I mean, you get around that by building this out as, like a Kubernetes or a clustered or a containerized application where you can add more nodes. And that's fine. I can do that as well. It's just I so happen to have a single node right now that's running this workload, which causes some other issues as well. But I've been bottlenecking this on purpose. So, yeah. So right now it should be the number of connections should be increasing to at least a couple hundred.
And one problem that we have with Python is because it was not designed to be multi-core, right? So even if you create 1,000 threads in your Python, unless you're using C Python,
I'm using processes, so these are spinning off individual processes.
Oh, okay.
So yeah, so each one should be able to handle, but it's still going to have some weight things. But you can look; those connections are increasing.
It is. So we have more than 100 connection open here, and now it went down.
That's probably because, let's see. Yeah, it's probably because this workload's randomized, so it will continue to change and evolve over time. That's
fine.
But here, yes, I want to overwrite it because, yeah, that's what happened. So now it should go back up to those, connections in a few seconds here. It'll bounce back up. There's actually just a configuration file that has the number of connections for each type of workload you want. And I just randomly change that every 5 minutes or so to adjust the workload. So you get these nice graphs that go up and down because, one of the biggest problems you see with benchmarking is when you have a consistent workload, it is a false workload, right? No one runs consistently at whether it's 80% or 100% or 60%. You see spikes up and down based on, what's happening in that time frame. So I figured every 5 minutes a randomization will work. I can also, run it so it is parallel. So, one of the other databases we have up here has been running the exact same workload for a week, and you will see almost no deviation from its parameters, right? It's just kind of consistent across the board, maybe plus or minus like a 5% change. So that's one of those really interesting things that you have to be mindful of and avoid. But look at that. See, just for you, Charlie, I generated more, and more.
Nice. So
everyone, Charlie asked for more connections, just like, we need more cowbell in most songs.
And my question is, do we have actually more throughput with more connections?
Probably not. I think that there's going to be a couple limiting factors here, right? So, because even though these are processes on Python, you're going to have the application server still has to receive the results and do some processing, which is going to take some CPU cycles as well. So in this case, adding more connections, you could also be hitting your CPU limit on the database server, which means that more connections is just going to flood the gates here. So take a look at what's the CPU right now. I'm guessing it's going to be pretty darn high. You're hitting 100%, right?
Yep.
So you are maxing out the CPU. So adding another 1,000 connections here isn't going to do anything.
And this is important, a really important realization, especially for when it comes for development, right? So it's a really common task. The development teams, they see, look, the application is slow because, well, the database is behaving slowly. Can we have more connections to the database? So we open more connections. We have more processing in parallel on the application side. And it's pretty common that we do not realize that open more connection doesn't mean that more data are coming from the database. We just have more connections waiting for the data from the database side.
Right.
Yeah. And as we are putting more and more load, the database is the results gonna be stressed and saturated. Now, instead of be faster, we're slower because we have a lot more saturation.
Yeah. And if you go to real quick, go under like the dashboards to go to a custom dashboard. So if you go to the side and hit manage, so like the side menu bar. Yeah. So go up one. Then go to manage and scroll down, I believe. Yeah. So there's a PMM test Postgres only dashboard. Click on that guy.
Yeah.
No, that's the MySQL one. You click the MySQL one. Don't go to MySQL. I have one for all databases that puts these together, but the Postgres one alone is designed and optimized just for Postgres.
Yeah.
So this is where, if we look, and you're on 111, so you're going to have to change the node to 130. We should be able to look at the response time in here. And so we get this response time graph. It'll be interesting to see if you go back the last hour, if you notice any sort of like improvement or degradation on the response time itself. So you can see that there's a more sustained spike in that kind of 6 milliseconds. And we did get a pretty big jump in the number of queries per second, though. Look at that. We're almost at 30,000. So we are processing more, but it is taking a little longer to process, it looks like.
Yeah, that's the thing. And there are a lot more the number of connections to improve performance, right? So if we try to put more, also we can be flooding your network.
That's another big question. Yeah. I've seen that before where the network pipe, the bandwidth between two servers just gets absolutely saturated and bogged down.
Exactly. And if you take a look here, see if at some point it's start going down, because this is what happens. Okay, we are starting fresh now. As we start fresh and we don't have cache, fine. So we take some time to warm up the cache. And eventually, as we have too many connections, too many transactions at the same time, the cache became too small. So we never actually get to a warm cache because it needs to be replaced too often.
Right.
Right. So that can also be another problem when we have too many connections. And one thing that can happen is when we have a connection pool in front of the database, is also to have an external caching system like
Redis or Memcache.
Redis. Yeah, yes, exactly. Memcache or Redis.
Anybody
Yeah,
still using Memcache out there? I mean, when I was around, that was the thing, right? I mean, that was kind of pre-Redis though, but God, am I dating myself? Yes. I'm so old.
They do.
We're like two grumpy old men, Charlie. Did you? By the way, did you see that the new stream cover? For our stream, if you haven't, you can take a look there. Oop, let's see. So, what do you think? I thought we should caption it "Two grumpy old men talking Postgres." Because we look kind of sad there, right? I mean, I don't know what is, that's, I think it's an interesting cover there for us. Definitely.
Well, yeah, we can have a pool on it, right? So
yeah, we can have a poll. We can have lots of polls. I don't know if we want, I mean, like, so,
look at here.
I mean, obviously, there's other things we could do. So this is the other one that the team came up with. I don't know. What do you think of this one? With Chino and the Haas here, we can definitely.
I'm all open for those ideas. New ideas.
So Chino and the Haas. All right. So, anyways, back to our beloved graphs and charts. Now that we've taken that outside, we could play Stump the Charlie later on.
Look how the latency is going here, and how the available memory is going down here, right?
Yeah.
So I think that the machine is getting quite degraded.
There's a lot of red on that machine there, and they're like look at the red. That's just like like the CPU. It's like blood red. It's like bleeding out of its eyeballs.
It is. Well, I quite like your dashboard here. Discuss.
Oh, wait, hold on. I just need to bask in that moment that Charlie quite likes my dashboard. Everyone, the stream has ended. There is nothing more that I can do. I have made Charlie like my dashboard, and he gave me a compliment. He didn't try and stump me. I'm done. Microphone drop. I'm done. I retire.
That's not good for my image. Like those.
That you're that difficult to deal with. That I sit there. Boom, mic drop. No. So Charlie, this was actually built with the support engineers, and you actually gave me details on what to look for and things. So I added everything that all of the support engineers to this dashboard. I personally think this should be the default dashboard. I mean, I'm just going to tell you that right now, that I'm like, this should totally be it right here. And it should just be done. Like, this should be the default for Postgres, but I do not get that say. If you're watching this later on and you're like, that's an awesome dashboard, it is available on GitHub right now. So, I can point you to the right direction. All this wonderful stuff, including the thing that's making this workload, is out there as well.
Yeah, and this is one thing that I really like on PMM. It's extensibility, right? So it's easy for anybody out there to get it and make amazing features and dashboards like this one.
Yeah.
So it's very extensible. One can say, oh, but it doesn't have everything. Well, maybe that's the trick. It doesn't have everything, but it's open for anybody to implement anything that they want to, right?
You want to see something cool? You want to see something cool? You want to see something cool?
You can plug your coffee machine here and get data from it.
Yeah, you can. But you want to see something cool? Scroll up.
Yep.
Scroll up to my query view. Okay. Find a query that you want a little bit more information on. You might have to scroll to the right to get like the metrics.
Okay.
Yeah, like there you go. So if you wanted to look at like the one that has the highest average time or max time, like choose one.
Let's
like,
just
yeah. Look at this. See, so this is where you can get the heat chart for that one particular query, the response time just for that one query, how many queries per second that's running. And if you scroll down, you can see visually how each one of those queries ran and get a nice little kind of like histogram of that. So boom, mic drop. Anyways, that was not why we're here. So Charly, back to tuning this instance.
Okay.
But thank you for the praise. I feel accomplished. I am retiring as king of the PMM dashboards and king of the streams. Thank you all for participating. But Charly,
right.
we're here to see what else we can do. Obviously the workload has changed again. So, things have adjusted. Like I said, users will come and go on the system. And during the busy times you saw, we got up to like 300 connections. But like any other real production workload, you're going to have spikes and you're going to have things that drop, right? And I think that's one of the challenges of any sort of tuning exercise is as you look at workload, what was happening 5 minutes ago might not happen again for another day.
Exactly.
And that up and down sort of mentality means that having the ability to go back and kind of drill into any one point in time and see what was causing issues is really important.
It is. Let's take a look here. We see this period of time here that the database had quite a lot of connections.
A bazillion. Right? I think it's a bazillion.
Yeah,
I think that's the official like metric for the number. It had a bazillion queries running.
Yeah, that's a very accurate math, bazillion.
Yes, bazillions.
I like. Yeah,
it's very close to Brazilians, but not quite the same.
Well, yeah, exactly, not quite the same. So let's take a look here.
It's okay. Charly's from Brazil, so I can say Brazilians because he's Brazilian.
Yeah, I am definitely.
So the Brazilian is looking at bazillions of queries. It's a pun. It's like a dad joke, right? That still plays. It's a horrible joke. Okay, go on.
No, you got me laughing. Right? That's not so
yes. Bad. Yes.
So let's back here to our job, right? So one interesting thing that we can take a look is as when the load started increasing, actually the number of tuples they went down.
Yes.
Right. So if you see here, we have a lot of tuples, and when we have a lot of more active connections, well, looks like that the data that's being out from the database did not correspond to the increased number of the connections, right? So, and we need to investigate why, right? So usually you want to look at the OS at the very same time, same period of time, right? So okay, we did it. We should have. Okay, let's take a look. I'll come back here just in a few. What I want to see here in my node summary. And I want to select, oops, not this one. So let's make sure that we have exactly the same that we want here. And here. So we're looking at the very same time range, right?
By the way, Charly, I think that if you go back to the one that had the original time range, you can right click on the node summary and open up a new tab that will keep those consistent numbers.
It would.
Okay. I just wanted to let people know. Wow, that had a load average of 63 on the box, by the way. Did you see that? Oh my gosh, that box is ready to fall over.
Yeah.
That's a pretty high load average.
Why is it a high load average? How can we tell if a load average is high or low?
Well, so I mean that load average is the number of runnable processes that are on the box, right? So, that's available to be run. So if you've got, let's say, 8 cores, a load average of 8 is probably going to be okay, maybe give or take a little bit. But if you're 10x that means that there is naturally a bottleneck because you have more runnable things than can run at any one time.
Yeah, that's quite good. And
of course, it's good.
Another thing that you need to pay attention to keep in mind is on Linux, how load average is calculated is quite weird. It also takes in consideration I/O process running.
Yes.
Right. So if you go for another Unix system, it's most of them really take in consideration the process running. And like, for example, the process on uninterruptible state that's just waiting for I/O. They are usually not taken into consideration for load average. And this doesn't quite happen on Linux, right? So I honestly don't know if it's good or bad, but we just need to also take those things in consideration.
Yeah, I mean, but just looking at these graphs, I mean, so not only are we at 100% CPU, but you're saturated.
Yeah. The saturation here.
You're totally consuming all the cores.
Exactly.
Now, interestingly enough, that process graph has a rounded curve to it. It's kind of interesting. Like it looks almost like a planet's part of a planet, like the horizon or something. It's a very interesting graph from a view perspective.
You're looking to the horizon, right?
Yeah,
it is.
Yes.
And we can start finding some answers here. Well, first things you had said, well, CPU is saturated, right? So definitely it's crashed. The load average for an 8 CPU cores of 63, it's not ideal. Definitely
not ideal. Let's be honest. Yeah. It's like
it's horrible.
Apocalyptic. Right? That's apocalyptic.
It's horrible.
Yes, yeah. If you're at like that much, yeah, that's apocalyptic.
Yeah. So that's the first problem, right? So clearly this box is not able to handle this load, right? And here you can see the context switching rise and up with something that we usually do not expect when we have so many connections and the CPU is being smashed. We expect to see a lot more context switching. So usually, not all the time, but usually when I see this pattern here from a box that is smashed by huge load, it smells like I/O problems as well. So our CPU is starting to waiting for I/O. Things can also get quite bad. And if you see here, the I/O latency, it's been crazy. See, we see up to 16 milliseconds, sometimes close to 20 and 30 milliseconds of I/O latency.
Right.
So this is crazy. If we're thinking about like you're asking for something to your disk, and before you start getting anything back, you need to wait for 15 milliseconds. From CPU point of view, it's like an eternity, right? So it's never, right? And that's why probably the main reason we don't see like so huge spikes here. If we take a look, when it's increasing here, see when the I/O latency increases here, we see the number of context switching going down, because now, well, CPU has nothing to do other than wait. Why does it need to switch any context? And when it's starting to get back the data back from the I/O, then okay, CPU starts working quite a lot again, right? So this is interesting. So we have two main problems here at this moment. That huge number of connections, they didn't increase performance because, well, they're smashing our CPU and they causing a lot of IO problems to our IO, right? So, and if you see here, the IO activity gonna slow down because, well, the IO queue goes so high, it's so extreme that the disk doesn't process it.
Yeah, it
It
can't keep.
hasn't
Yeah.
ability to keep up with this, right? So those are the results of what we did. Well, at this point, for this box, without changing any configuration, so the better thing that we could do is to put a connection pooling like a PG bounce or AJ proxy in front of this box and limit the number of connections to the database, right? So probably taking it back to 100, 150 max connections would be the best. And look at the TCP retransmission here. It's also bad indication. It's not that high, but like it was it was lower before, right? So everything starts to get messed. And the network traffic, as expected, as now we have 1,000 connections, sending a lot of things to the database. We would get the network probably flooded as well. Yeah. So for this investigation here, 1,000 connections is definitely too bad, right? For two main reasons that we have. So, but what we put it back to 500. Do you think the application, the box would be able to handle 500?
Well, keep in mind, while we had 1,000 connections, we only ramped up here to around 300. So if you look at the
Oh,
overall number of connections here, we didn't even hit the 500 or the 1,000.
that's a good point. That's a good point. Let me.
Yeah, see right there. So you do see a couple spikes that hit up to like 500, but it's very rare. For most of the time, it wasn't.
Yeah, most of the time we're below 300 actually.
Yeah. So I only added about 300. Now again, I could throw 1,000, but it was already dead then.
No. We already crashed it.
Yeah, yeah. Unless we want to, do that again.
No, it's
Danielle,
fine.
welcome. Thanks for joining. Thanks for saying hi.
And well, that's what we saw from the OS point of view, right? Now let's take a look on the database point of view. So, okay, I just want to go back to, okay, here is where we started. So when we start getting a whole a load that is too high, one thing that we should expect is to increase the number of locks inside of the database, right? So there are many different types of locks on the database, but the overall number of locks in general should spike. And yeah, this is. So this is around when the time that the load start, right? So if we see the number of locks, they're not that bad. And then things start getting quite high here, right?
And if you
So
compare that to now, so if you draw out your graph and look now, or look, starting, like just change the 2 to now. Just change,
okay.
yeah, and
I'm trying to.
yeah.
It's loading.
There you go. And so if you come down there, you can see like once those connections went back to a normal workload, because keep in mind, we ramped that workload up to 300. Whereas normally it was running in the, let's say 50 to 120 range on a normal given day. You can definitely see that change. You can also see that, there's a workload change that just happened as well. So you see like and so you can see those workload changes directly in that graph.
Yeah, that's pretty clear. So that's pretty clear.
See,
And
look at that.
this
Wow. We're finding out stuff.
and this impact we could see on the throughput, right? So
Yep.
how impactful the rising of the number of locks was to the throughput. That even though we had like 3, 4, 5 times number of the connections that we usually have, the throughput went down instead of going up.
And a good
right?
way to see this is if you go back to my tab. So go to the tab with my this one, and go ahead and refresh this real quick because yeah, we just want to see what the latest is. So we should see that that kind of spike there.
Yep.
So go ahead and just highlight, let's say the last since from 1530 where it yeah,
1
maybe the
hour.
last hour. Yeah. Last hour should be good. You
Yeah.
so you see the spike in the DB connections up to that 300. If you go down and choose one of the queries, we can look at the histogram for that particular query and look at don't do an update, do a like select, probably be easier, I think.
Yeah, here.
Yeah, we can look at the throughput for those or the latency for each of the queries, and you can see how long each one takes. And so we should be able to see that spike. Yeah, so you see like the spike, started to go up
Exactly.
with that.
The response time here is increases like it's crazy.
Yeah, and then it dropped back down once those connections went away. So the more connections, the more bottleneck, the slower things got.
Exactly.
But yeah, and I mean, you can see that in this as well, where you start to scroll down, and then like look at that one right there. You see that one that just like boop right at the top. It was like, oh my god, this is ready to die, and then it came back down. And that's kind of like what your end users are going to experience, right? If this is a query that's something that's run quite frequently.
Exactly. And this is the point. Just increasing the number of connections doesn't make things faster.
Yep.
And it can go it can goes backwards, right? Rising too much the number of connections can just degrade the performance horrendously, right? As we saw here.
Yep. Okay.
Right.
So Charlie, we're about out of time.
Okay.
Because we said, Charlie wants one more thing. He wants to check the checkpoints.
Just the checkpoints here. If you see here, around that time, see how your checkpoints is around like 5 minutes, 10 minutes sometimes. I just want to select here. This is one thing that we can change on the configuration, and we can adjust for your workload. We don't want a checkpoint every 5 minutes or every 3 minutes, right? So we want the checkpoint to be more evenly distributed in your workload because, well, it can reduce pressure on I/O, right? So, well, those here during the peak, the high number of connections that we had, we can clearly see how much more checkpoints, how more frequently the checkpoints were, right? So if we cannot reduce the number of connections, one thing that you definitely need to do from Postgres is adjust the checkpoints configuration. Because this we can reduce a little bit. It won't make magic, but it will help, especially with the I/O. Remember that when we saw the I/O, it's not this one, well somewhere here, we saw the I/O.
Yeah.
It also got really smashed, and
Yep.
the latency went horrible. So the checkpoints, they contribute a lot to this problem. So if we change some settings related to the checkpoint, we can have just one section focus on the checkpoints and how we do that. I think that would be really good. So we could improve the problem, but we're still going to have the problem related to the CPU and a lot of I/O and network and bandwidth coming in. But like at least we're tackling some problems some points that we can, right?
Yep.
So this is one area that we definitely. Another one that I will just mention here, we won't have time to check today, are about the vacuum. So, but vacuum is a topic that deserves one whole talk,
An
whole stream.
entire vacuum talk.
Yes. So, but yeah, this is also another thing that we will probably need to take a look, and can also help to improve that the IO issues that we had there. Yeah, those are all my last things that I wanted to share for today. I think we're on top of the hour. We've discussed a lot.
We did, and so Charly, let's go ahead and flip your camera back to just you, and we will bring you back in for the reveal of the Peter hat. So I went to lunch with Peter, our CEO, today, and he told me that he bought me this hat. This hat is evidently made of ram. It's a ram hat. So this is like ram fur or something. So I'm going to put it on just for all you. And he told me I needed to smell it because it
It's
smells
so
like
fluffy.
ram. Well, the dogs think it's a chew toy.
Oh,
but
really?
Yeah. Oh, yeah. The dogs got
Oh,
really excited when I brought this in.
Like a chew toy?
Oh, yeah. They were jumping all over trying to get at it. Because this is like what you would like they have these toys you could buy at the pet store that are like this, right?
Yeah, I know. Yeah.
It looks like a Tribble maybe from Star Trek. So okay, let's do the hat change. So you could still hear me, but I can't hear you for a second. So let's see. So let's see. Evidently, I'm supposed to get it as low as possible. It doesn't really work with the headphones very well.
I can tell.
It actually looks like a wig. I don't know.
Yep.
You know, I mean, like maybe other people can tell me this actually doesn't look like a hat at all. It looks like a wig. It looks like a fancy dress wig.
It does. But before you put the headphone, there are some dresses, some hats on Asia, on Mongolia, and then that they have some hats there. It looks like those ones.
Do they? Know? Okay. All right. Well, then
yeah,
great.
They do. I think
so.
Made
this
out of camel, flour, something like that.
Looks good. You know, that's cool. I'm happy. Like, you know, anytime somebody wants to send me a hat, I'll wear it. Although, like I said, this totally makes it look like this is my hair. Like on camera, I think this makes it look like I've got a big white head of hair. You know,
it does look like a wig.
It does. It does not look like a hat. You know, and Daniela was telling me, like, you know, you got to get this hat for Peter. It's so awesome. It's so awesome. It's so awesome. And I got it. And now it looks like I'm wearing a freaking wig. I mean,
okay.
Thank you, Peter, for the hat. Like I said, I love hats. I have a hat collection. I've got like thousands in the house, you know, but this totally looks like a wig when I look at it on camera. What does everybody else think? Comment, does this look like a wig or a hat? I think it looks like a wig, and it probably is more hair than I have right now anyway. So maybe I'll just wear this for the rest of my days and people will just think I'm cool.
Well, and it probably be quite warm and comfortable during winter, right?
Yeah, and unfortunately it doesn't get very cold here. Yes, Danielle, you saw the hat. Yes, wonderful. It doesn't look like a hat. It looks like a wig. Like, you know,
yeah, it does.
I'm like Mozart or something, you know, back in the day when they wore the white wigs. Or I could, yeah, I don't know. But okay, so here's what's coming up. So next week, Charly is back with us at our regular scheduled time. Like I said, this is not a regular scheduled live stream. So if you see this and you're like, what the heck, did I miss it? No, you didn't miss it. We just didn't finish last week. So we wanted to come back, cover a few different things. Next week, what we're going to do is we're going to take these same instances and Charly's going to come along and configure the alerts. And we're going to talk about what sort of things we should be monitoring in a production system and what are sane thresholds for those production systems.
Yep. We're going to start them.
A gray-haired Marge. Wait, Danielle, it's not gray, it's white. Why would I look like a gray-haired Marge Simpson? No, it's white. This is white. It's not gray. Maybe a white-haired Marge Simpson, but I think it needs to go like this high.
Yeah, it needs to go like quite a lot.
Yeah. Anyway, so yes, Charly, next week, alerts. Be prepared.
Yeah.
Be prepared. Be prepared.
I'll keep an alert about next week. I'll keep it.
Yes. Great,
I know
Daniel.
it's
You
not
look forward
horrible.
to alerts, and maybe I'll wear this hat for the alerts. We'll alert you to this hat coming.
All right.
All right. Fair enough. And so for the two grumpy old men, Chino and the Haas, we thank you very much for showing up today and watching the stream. And tune in next week for the discussion on alerting. Woohoo! Alerting everybody. All right.
Yeah, keep eyes on it.
Yes. Thanks a bunch. We will